All right, hello there. So we're welcome to July 18th, 1969. We are now 2 days and 10 hours mission elapsed time since launch. The CM is now, let's see here, 185,000 nautical miles out from Earth. Looking over at the S4 booster, it is now 12 nautical miles away, drifting. And this is the view. So looking towards Earth. You can even see the gantry there on the limb. And this green spot here is the S4 booster. You can pick the booster and see what view the booster has. So it's looking towards the CM right there. And if we turn a little bit to the right, there's the moon. And the moon is 28,000 nautical miles away. So really our frame of reference now should be the moon. So let's go back to the CM, change our orbit to moon. Alright, so yesterday our closest approach, our perilune periapsis to the moon was 3,000 something nautical miles. And we calculated it was coming down at a rate of about 5 nautical miles a minute, hoping that after about 10 hours or so it would be down. But as you can see, we're now at 2 days and 10 hours, and it's only down to 1,000 nautical miles. So the rate of change, the rate of decrease is not constant. It slows down. So let's figure out what it is right now, and then we'll have to do a mid-course correction and get that perilune down to about 60 nautical miles. Alright, so let's switch over to our 2D. Give me a time plot. Okay. So it's saying our closest approach is going to be about 1,000 nautical miles. This is where it'll be. So let's see how long that'll take. Looking down here, time of flight, 11 hours. So about 11 hours 52, so let's say 12 hours. So 12 hours to get to the closest point, which is where we'll be doing our orbit insertion burn into lunar orbit. And we really want the closest approach, or the periapsis, to be 60 nautical miles. So let's see how long this is taking. The time now, let's see when it gets to 10:18. 2 days, 10 hours, 45. 2 days, 10 hours, 45. Okay, 2 days, 10 hours, 45 and a half. Let's see how long it takes to get to 17. 45 and a half it was. 45 and a half. Okay, 46. 52. All right, so 45 to 46, 52. Let's just roughly say that's a minute. So it's now taking a minute for the periloon to drop by 1 nautical mile. So 1 mile a minute, 60 miles in an hour, and time of flight to closest approach is about 12 hours. So 720 miles. So if it was constant, we could subtract 720, assume it would get down to about, let's just say 300 at time of closest, and we could just shave off 240 right now and call it good. But we know the rate's gonna go much slower the closer we get to the moon, and that's by the way, the periapsis is changing because we have gravity from the moon. We also still have it from the Earth, so this orbit is changing. All right, so let's see what we got to work with here. So I'm not gonna take it down to, I'm not gonna assume we're gonna get 700 taken off. Let's say we might get maybe a fifth of that. Maybe we might get, I don't know, about 200 taken off. So let's, to make it go to 60, let's say we'll take off, we'll take it down to 360, let's take it down to 250, and then we'll assume that a little bit will be done by the periloon dipping. So let's do a plot course correction. Alright, so we want to take it down to 250, so this is our target periloon. Taking it down to 250. That's about it. Now if you look here at your transfer speed, that's the budget. That's how much it's gonna cost. Well, this is our budget, 5221 feet per second. We don't want to spend too much of that because we need to do the mid-course correction now. We might have to do another one tomorrow, and then we have to burn into orbit, burn out of orbit to get back to Earth. So we want to use the minimum. So let's see, 250 is what we're aiming at, and I'm just going to change the angle because, as you can see, changing the angle greatly modifies how much fuel is used. So it looks like going this way makes it less. So, oops. Yeah, so we've got a minimum around here, 125. Let's go to 250. See the least we can get away with. 121. 120. Alright. Selected. The ship is now turning, has turned to the burn attitude. It's going to be in 1 minute. It's going to be a 6-minute burn. So I'm going to increase the thrust to 100. We'll use the main engine. Alright, so 18-second burn. So just like we always do, I'm going to fire it at 9 seconds. It's an 18-second burn, so 9 seconds we'll fire it. There we go. Complete. Alright, so it's given us a periapsis of 252. We wanted 250. 252 is good enough for now. Alright, so let's place it in velocity positive mode. That's the view of the moon right now. In actual fact, the astronauts would not have seen it since it's a new moon. In our case here, they just see a circle that was really black and devoid of any stars. That's how they knew where the moon was. But in this simulation, we're actually showing you, so you have something to look at. All right, so here we go. This is our new trajectory. Let's get a time plot. (11 hours 16 minutes) until we go into orbit. So let's just set a timer. Let us know in 5 hours, and we'll see what the periapsis looks like. We'll probably have to do one more mid-course correction to get that where we want it to be, and then we'll be going into lunar orbit in about 11 hours. Alright, so that's it for today, July 18th, continuing the coast, and then in a few hours we'll see what we have to do a mid-course.